Hi everyone, welcome to another devlog of Marsozoic, my alien paleontology game. Today we'll talk about how I started developing the research side of the game, with in-game books you can leaf through and the basics of an interactive keyword system, among other things. So in the previous videos, I spent a lot of time on the skeleton assembly part of the game, so the ability to put bones together and also to simulate muscle movement between them. That's got to an okay state for now, so I decided to start on some brand new features. In Marsozoic, I want players to be able to study the fossils and draw conclusions about the alien animal from some of the bone's features, and to do that they have access to various sources of information in their lab, such as books. In the paper proto of Marsozoic, I prepared all those little printed books, and so it's now time to bring those books into the digital version of the game. So to start with, I picked up my pencil and drew my imagined layout of the player's lab, with some parts of the lab I want the player to have access to. So there's a table where the fossils are assembled, another table for research, the fossil storage, the library storing the books, and a map of Mars. This is just a design sketch. The lab may never appear exactly like this in the game, but visualizing the space like this will help me put the different screens together and create nice transitions between them. Speaking of transitions, I started by creating this new split screen state, where you'll be able to both access the fossils you're currently studying on the left, while having books and research materials visible on the right. In our layout sketch, this is like we're looking down on both tables at once, like this, with a scaling trick to still fit all the fossils on the table into the view. And then I created this simple animation to move from one state to the other. So if you want to fully focus on fossil assembly, you can have the fossil space fill the entire screen, and then you can return to the split research view where you can compare the fossils with information you have available. Since we're meant to have those two tables at uneven heights, I had the transition reflect that, so you pull upwards from the fossil table. This also helps with a scaling trick on the fossil that lets me fit all of them into the split view. You may remember that we're using an orthographic camera, which doesn't show depth, so the change in depth in this animation is entirely cheated by scaling the objects in front of the camera while it moves. It was then time to create an actual book, so I went and found public domain pictures of books and edited them to make simple sprites for a closed and an open book. I made a 2D page template, then made a bunch of scenes out of that template reusing the content I wrote for the paper prototype. Then I made it possible to feed a list of those page scenes into a book object. I put mouse colliders on each side of the book, and I wrote simple navigation code so that when you click on those colliders, both pages of the open book would load in the correct next page. And that gave me a simple working version of a book. This would have been enough for a start, so I should really have just moved on to another feature at that point, but I just really wanted a nice actual turning page effect, so I went into Blender and made one. I created a flat page, put a super simple rig on it, and animated it. I had not really done any animation in Blender before, so something really simple like this was a great way to learn the basics of rigging and weight painting. But now I had to get the content of my pages to properly load and show up on this 3D object. Thankfully, there's a node in Godot that lets you project content on another object as a texture. It's called a sub-viewport. It's really useful to make screens in your game or take pictures, for example. In our case, it allows us to take our 2D pages and project them cleanly onto our 3D page. So now when you click to turn the page, you load the proper page content on both sides of the turning page, you play the turning page animation, you switch the content on the actual book pages while they're hidden by the turning page, and then you erase the turning page when it has actually finished turning. And there you go, seamless illusion. And from there, of course, I also wanted the cover to properly open and close, so I made a 3D model of the entire book and also animated it in Blender. I went back to my simple book sprites and turned them into a simple texture for the 3D object, which was a great opportunity to try my hand at simple UV mapping. It turns out, if you'd like to learn several aspects of Blender at once, like UV mapping and rigging and animating, then making a book is a really great way to do that, because it's a simple object, but you're going to touch on a lot of things to make it work. And here it is in game, a functional 3D book. You can even turn several pages at once. By the way, at this point you may be wondering why I want the research to happen in books if the setting is a lab on Mars. Like, that seems a little anachronistic. I could, be making screens or something and not have to bother with the animation of a book. But there is a narrative reason why I want it to be books. I don't want to get into it too much right now, but the narrative of the game is slowly coalescing in my head, and books will just kind of work better for it. And also, books are just really cool physical objects that feel nice to manipulate, and hopefully that will also be the case in the game, just like the fossils. So now, how are those books meant to be used in-game? I want players to be able to pluck important words and concepts straight out of the pages to fill in the answers of the deductions. So similar to the Golden Idol system, but getting the words straight from the text on the pages. So I would need to define some words inside the text as keywords that would then become those little interactable capsules. Now, I have been warned in my career that text is awful to deal with in games. Like colleagues working on subtitles, for example, have told me it's always more complicated than you think. And yet, I was not ready. I basically needed to replace some words with interactive game objects, the capsules, that would be placed in the same spots as the words. That meant that I needed to get the word itself, but also its position inside the text box, where it was actually rendered on the screen. And that last part, that was something. Because without getting into technical details too much, that's something that only the low-level text rendering server knows. It's not a property of the text that's easily accessible in the text box object in Godot. There is a Godot PR to expose this info, but it's not merged at the moment, so I would have to compile it into the engine myself. I could, but for this project I'd really rather stay with the base engine as long as possible, to not have to deal with potential update issues later. A lot of games get around these types of issues by using fonts and formatting that let you calculate the letters' positions. For example, monospace fonts have each letter take up the same width in pixels, so you can count the letters from the start of a line, multiply that with the standard width of a letter, and you'll always get the correct offset in pixels. It's also easier to calculate this kind of thing if the text is aligned to the left or the right of the text box. Because if your text is justified, the width of the spaces between words can change, of course. So the smart thing to do would be to use a monospace font on left-aligned text for simplicity. But you see, I'm an idiot, and I didn't want to do either of those things, because I figured it's text inside a book, so it should look fancy, I should be able to use whatever type of font I need, and it should be justified. So I ended up making a wild hack of the Godot BBCode system. BBCode is that syntax where you use tags in the text to format it. It used to be a thing on forums. Godot text boxes use it, and the Godot BBCode system actually does know where each letter is on the screen, because normally it lets you use this info to animate the letters, for example. And the great thing is that system also removes BBCode tags on its own as it parses them. So that also just gives me an exploitable tag system without me having to worry about removing the tags from the displayed text. So I wrote a special BBCode effect that creates those custom cap tags and pretty much only passes the position of the first letter of the tagged word back to the text box object. Then, on the text box itself, there's code that uses those same tags to find the actual word between the tags and create an interactable capsule containing that word, and places it properly using the positional info it just got from the BBCode hack. I even got this to work live in the editor while I'm editing text. The capsules get generated and placed on the fly when I type in the tags. The great thing is that this works with justified text and non-monospace fonts, because it gets the positional information from the text server through the BBCode, and since it's just tags, the capsule words can be anywhere in the text. So I think this should still work in the magical fantasy land where this game gets localized in the future. The keywords have to be sorted into different categories that will give their capsules distinct colors to make things easier for players. Again, taking cues from Golden Idol here. So I want to have a database of keywords in the game, with each keyword being associated to various properties. So I created a custom keyword resource in Godot, and then I installed this add-on, Yard, to be able to see and edit them in a big spreadsheet in the editor. Yard lets you make filtered spreadsheets of your custom resources in Godot, and it also provides you with faster ways to query some properties of those resources at runtime. I first heard about it at GodotCon just last month. It was exactly what I needed. I even created a little PR for the add-on with some changes that would allow users to add values to the spreadsheet much faster, and after some back and forth changes, it got merged, making this my very first merged open source contribution. So I used Yarn to create a table of keywords. Now, when I tag a word in page text, I can add the keyword key inside the tag, and the created capsule will be associated with that keyword. It will immediately get the correct category color, and more importantly, this lets me link many versions of the same word to the same keyword. For example, singular and plural versions of a word or conjugated versions of a verb can all be correctly linked to the same basic keyword in the system. This will be super useful later to give players the ability to find all occurrences of a concept in the various books without them having to make an exact text search. So for example, if you search for tooth, it should also link you to teeth. From there, I just needed to give players the ability to pick up the encapsulated words to drag them into solution sheets. This was a little harder than it looks here, because if you remember, the page content is actually a texture that's projected on the 3D page, so the capsule isn't actually there to be clicked on. So I had to write a little code that transmits the 3D coordinates of where you clicked on a page into the 2D scene of the page content and find out what you actually clicked on in there. And here you go. Now you can pick up words straight out of the book, and even better, as you can see here, the word in the text can be conjugated or modified however needed, but you'll still always pick up a basic neutral version of the keyword. Other little things I worked on. Maybe you noticed I added shadows on the fossils. Again, this is slightly cheated for the orthographic camera, so there's actually a transparent plane just behind the fossils that only displays their shadows. This lets me easily adjust them however I want. However, I am now wondering about maybe just switching back into a perspective camera. As you can see here, it does give the objects a little bit more presence and would save me some trickery to give the illusion of depth. At the same time, it will for sure cause other problems, and it may make the books a little less readable and make it harder to assemble fossils. So I'll do some tests, but of course the priority should remain on clarity and playability. And that's it for now. As you may notice, I'm trying a shorter format. Longer videos just take too much time to make, and that's time that's not spent on the game. So this one is a bit less detailed, but hopefully it also makes for a snappier watch. Last super quick news. I gave a little presentation at GodotCon in April about simple ways to set up a little Blender to Godot pipeline, so detailing some of the stuff I talked about in the previous video. It should be uploaded on YouTube shortly if you're interested. I'll also be at Game Camp in Lille, so that's the gathering of French game dev professionals. If you're also going, don't hesitate to say hello. My goal is to have the game in pretty much the same state as the paper prototype by then, so ideally you should have access to all the same pieces and be able to make all the same deductions and fill in the solution sheet in the digital version of the game. That's it for today. Thank you very much for watching, and I'll see you next time.